Ransomware is a common threat, and ransomware is used by TA505 as well as some ransom gangs. And some of those gangs encrypt the data randomly or automatically or after some investigation. For example, a ransom gang will target a certain organization, get into it, and find the valuable data and encrypt the data and start exfiltration. Another ransom gang will only deploy the malware and integrate this to some automated exploits and just wait for this malware to spread itself. Another way is actually quite common. Sometimes the threat actors implement this ransoming specifically to certain files or certain servers. To simulate this safely, I developed a tool called Ransomware. So Ransomware is compiled here, and I will publish this tool on my Git repository as well as part of this exercise. And it is a simple tool. Actually, I implemented a simple encryption here. That's it. So it will encrypt a certain file and it won't delete it. Normally, ransomware encrypts the data or disk, and it also alters the operating system. Sometimes it even works on the boot sequence of the operating system as well. And it is not only specific to Windows, it works everywhere. So what I need to do here is only implementing this encryption safely, and that's it. That's why I have this code segment here. Currently, I don't accept parameters for key strings or IV strings. I use hard-coded, so you can change this and you can compile this using mono again. And it is also here as functions, encrypt as well as decrypt. We have two functions here implementing the encryption, and it is actually using AES, so it can encrypt the data as it won't touch any disk, they won't see any binary, and the key won't be visible unless they use event tracing for Windows. You can always give this as a parameter, so even the file is there, it won't be visible at all. Or you can use public encryption if you want to change your implementation. My implementation is quite simple, using AES and giving the input buffer for encryption or decryption. How it works is quite simple, giving the parameters like this: ransomware, encrypt the target file, and it will encrypt this. And if there is no output file name, it will use output file name as target file.enc. For decryption, given target file will be decrypted and DEC will be added in the end of it. It won't delete any file because of the safety requirements. So if you really need to delete something, you can delete, but you can encrypt things like that. So let's see this in action. Let's use one of the implants here. And we can see that there are some files collected through our seatbelt. If we go to our seatbelt output, we can see some Office files listed as used files and Office documents. So what we can do here is just finding those files, listing those files, and encrypting them. So we can create a loop, or we can just use that file. In this case, I'm using actually normal standard ways to show this manually. And this is exec.dir, and I'm using this for the user actually, because our user is Guido, and desktop or documents folders may have some sensitive content. And our sensitive content is here. Our sensitive content may have some additional features or additional content names or some different file types or some integrations. Ransomware doesn't support any of all. It will just encrypt and decrypt the file. So if file is complicated, file name is complicated, and etc., you need to patch this. Good news is the source code is available. So you can just work on the source code and the parameters and you can just modify, or you can implement your own ransomware. In this case, the sensitive content is here and it's a file under certainly right here. Sensitive content docx. The file is here. So let's see how we can run this. Exec sharp assembly and ransomware file ransomware, and the parameter is encrypt sensitive content. Let's hope it works. It says that it encrypted and Windows Defender said something. Let's see. Did it identify anything? It doesn't say anything. It identified something, but the data is encrypted here. Actually, good news is we always work with backups, as I previously described. So let's see our files are in the correct position and everything is aligned. The docx is there. And encrypted content is there as well. So what we can do is just deleting the content and making it a ransom like this. But remember that deleting something from a system doesn't mean that it is deleted. It can be always retrieved and restored. But our operation is here. I'm not sure why Windows Defender complained, but ransom link shouldn't be a problem. Maybe the ransom name is the challenge here. So I'm just copying the binary and scan with Windows Defender. It doesn't see any threat. So it suspected some of the actions and somehow broke our implant. As we work with backups, as we previously discussed already, because backup is quite important for us, we still have the access. And when we verify that, we encrypted the content. So we can decrypt this content again using the same command. And let's see, this session will be gone as well. Right? This is the content, and this time we will use the same parameter with decrypt, and this time we will give docx.enc and name this as sensitive content docx. And it should be straightforward, but if it's identified, we can see it. Any alert? No. I don't know why did that, but let's see. Our encryption worked. Yes, it worked. It can reverse things as well. So this is ransomware tool. What we did here is actually encrypting data. If we need to retrieve this data, we can just use download. This file. Now this file is with us as well. That means we can use this for ransoming, but in another way. For example, if this data is sensitive to publish, we can say that we will release this file on internet if you don't pay us, let's say, 2 galleons or 3 galleons. And yeah, this is the ransomware implementation.